All right, today, guys, we're going to talk about lesson 2.2, which deals with finding the slope of lines and dealing with linear equations, parallel, perpendicular lines, and finding the slopes of those. So, I think the way to start this is to go ahead and think about when we were in algebra class and talk about the slope formula. Okay, so I'm going to go ahead and I'm going to start off with your slope formula. And what letter did we go ahead and use for slope when we're talking about y equals mx plus b? Well, we know that we used the letter m. So we have slope equals y2 minus y1 over x2 minus x1. Okay? So, oh, my screen just died. So what we're looking at here is really we're looking at something that's known as the change in y over the change in x. And that delta symbol right there, that just means the change in y over the change in x. So I think it's very important when you start to take both your points, and you're always going to go ahead and label your first point x1, y1, and your second point x2, y2. Okay? And then you're going to go ahead and you're going to start your slope formula. So your m equals y2. So in this example, this right here is going to be my y2. All right, so I'm going to go 13 minus this right here is going to be my y1. So I have 13 minus 1 over x2, which is that, x1, which is that. So I'm going to write it as 2 minus 0. Okay? 13 minus 1 gives me 12. All right, 2 minus 0 gives me 2. We know that this right here simplifies to be 6 over 1, which really, guys, we know is going to be a slope of 6. Okay? That means we're going to go ahead in this one, we're going to rise 6, and we're going to run 1. So we would go up 6, so we'd go up 6 over 1, and we'd make a point, we'd make another point, and then we'd be able to graph our line using that type of idea. Okay? So rise over run, all right, that's what we're looking at. Change in x over change in y is our slope formula. I think it's real important when you're doing these. Let's take a look at number 5 and number 6 right here. And let's do the same thing. Let's go ahead and do my slope formula. We'll write that first. M equals, and then we'll label x1, y1, x2, y2. All right. So y2 minus y1, negative 5 minus a negative 5. Okay. Notice with this, guys, I took it and I put it in just as it was, as a negative 5. All right. x2 minus x1, I got 4 minus 0. So we're really looking at right here, guys, this and this together, that becomes a plus sign. So you have negative 5 plus 5, which would give you 0 over 4. This would come out to be a slope of 0. All right? So if it came out to be a slope of 0, if we're talking about rise over run, that means we're going up none, but we're going left or right 4. So this one right here, whenever you have a slope of 0, I want you to know that this is a horizontal line. Horizontal. All right? And this is always going to be a y equals type of graph. Okay? This one over here. Okay, we'll see how this one's a little bit different. Let's label x1, y1, x2, y2. All right, so 6 minus 3, we good with that? Negative 1 plus, excuse me, negative 1 minus negative 1 is going to give you negative 1 plus 1. So we're going to end up with 3 over 0. And this one right here, guys, whenever you have a 0 in the denominator, all right, your answer is going to be undefined. All right, in this one right here, undefined, what happens is we know that this is going to be a vertical line, up and down. And my vertical lines always go through a point on my x, so they're going to be an x equals. Okay, slope formula, very important. All right, these ones want to know whether or not the slope rises, falls, is horizontal or vertical. Well, what we just looked at up here we know for horizontal, we know we're going to have a slope equal to 0, right? And for vertical, we're going to have this. We're going to have a slope equal to undefined. So right away, just by looking at this, we know that number 9 right here is going to be what? It's going to be a horizontal line, all right? And we know that number 10 right here is going to be a vertical line, okay? Now, these ones, they're talking about rising and falling. Obviously, something that would rise would be something that has a positive slope, right? And something that falls would have a negative slope. So this one right here is going to be a line that rises. This one's going to be a line that falls. These ones right here, why don't we go ahead and use the slope formula first, and then we'll be able to decipher whether or not they rise or fall. Okay? Alright. Ooh, line is steeper. Alright. For these ones, what's going to happen is, which line is steeper? The greater the number, the more steep the line is. If you think about that, if you were to draw in your x and y axis, okay, imagine that this right here was the ground. Alright, that's the ground. And then this is you looking straight up to the sky. Alright, well, what's steeper? This, of you looking straight up this way, or you looking out like this? Okay, obviously, this one right here is going to be a steeper, right? Imagine climbing that mountain. What would you rather climb? This one right here, or this one right here? Okay? So this one right here, this is going to have a greater slope, and this would have a less slope. All right, so what we're going to do is we're going to figure out the slope of this one. So I'm going to take my 5 minus my 3, and I'm going to take my 6 minus my 0. I'm going to end up with a slope of 2, 6, which is equal to 1/3. This one right here probably looks more like the green ray that I drew over there, okay? Let's find out the slope for this one. I'm going to do 12 minus 6 over 8 minus 5, which is going to give me 6 over 3, which is equal to 2 over 1, which is going to equal 2. Rise 2, run 1. So you go up more than you do. So this one right here, since it has a bigger slope, that's going to be a steeper line. Questions? Good to go with that, I think? Alright. Alright. Parallel, perpendicular, or neither? Okay. Parallel lines. For parallel, I'm going to use this symbol right here. Alright. So that's going to stand for parallel lines. Oh, sorry. That's going to stand for parallel lines right there, okay? So here's what we know. Parallel lines, they always, always, always have the same slope. Alright? Parallel lines are going to look like this. You got your x-axis and y-axis. If I were to draw in parallel lines, they would look like this. This and this. They are never, ever, ever going to intersect. Alright? They're never going to intersect, and they're always going to have a slope that is exactly the same. So, an example of that one might be this one right here. We would know that line 1 is parallel to line 2. Look at what they have. Exact same slope. Okay? Alright. Perpendicular. Upside down T. Alright, forms a 90-degree angle. So we know that perpendicular lines, alright, they go ahead and they form right angles. Okay? So what we're going to do for that is we're going to write in what happens with perpendicular lines. Alright? Their slopes are opposite reciprocals. Opposite reciprocals. So here's the deal. If one of the slopes of one line is positive, all right, the other one has to be negative. For example, if you have a slope of negative 2/3. In order for a line to be perpendicular for it, you take the reciprocal and you do the opposite, 3/2. All right, let's say you have something like this, 4. Now we know that 4 is really 4/1, so we'd have to do the opposite reciprocal, so -1/4. Like this example right here. All right, in that example, we would say line 1 is perpendicular to line 2. All right, what about this one right here? Okay, 3 1/3. Well, we got reciprocals, but they're not opposite. So these ones right here, they have no relation. All right, they are not parallel, they are not perpendicular. We're going to say that they are neither of those. All right. All right, guys, this is really kind of what we're looking for in section 2.2. You should know the slope formula. You should know rise, run, vertical, horizontal, and you should know what parallel and perpendicular means. Okay, thank you.